In this video, I'll walk you through setting up routes and using sequelize models to interact with a database. We'll build a complete user resource, from defining a user model to creating, reading, updating, and deleting users via HTTP methods. I am in node.js project that has Express and sequels installed and is connected to a database. If you would like to learn how to do this setup, please check out this video. Let's open API test.http file. In this file, I added several routes. If you would like to follow along, as usual, the link to the GitHub repository is in the description. These routes represent a REST API. REST stands for Representational State Transfer. It relies on HTTP methods to manipulate resources. A resource is something your application provides access to, like users, posts, comments, and so on. In our case, we have a user resource. This resource is specified in the path part of the URL in plural form. HTTP methods in REST API allow us to perform different actions on those resources. For example, to list users or get a single user, we use HTTP method get. If we want to create a user, we use post method. To update a user, we use put method. There's also a patch method that you can use to update a resource. The difference between put and patch is that when using put method, the whole resource is replaced, but when using patch method, only some of the attributes of the resource are changed. In practice, it can get pretty tricky to determine if the whole resource is changed or only parts of it. When designing a REST API, I almost always use put method to update resources. Finally, delete HTTP method is used to delete a resource. How are resources represented in an application? Well, you have to store resource data somewhere. Usually, this somewhere is a database table. Sometimes a resource can be stored across multiple tables. For example, order information is stored in both orders and order lines tables. When programming, however, we don't use tables, but rather objects and models. Sequelize lets us define models in JavaScript and use intuitive methods to query and manipulate resource data. Let's create a user model in src data models folder. We are going to import creation optional, infer attributes, and infer creation attributes from Sequelize. Next, we will import a few things from sequelize-typescript. Most of them are decorators that we will use to annotate user model and model attributes. When defining a model with sequelize-typescript, we use a table decorator. I like to explicitly specify table name and model name. My convention is to name tables and columns in lowercase plural form, using snake case for multi-word names. I name models in singular form, with the first letter capitalized. Next, we will export default class user. This class will extend Sequelize model to which we will pass infer attributes and infer creation attributes for the user class. Attribute ID has a type of number. It will correspond to a primary key column of data type big integer. Since it will be auto-incremented by the database, we won't need to pass it when creating a user. Therefore, we will make the ID as creation optional. Next, we will declare name attribute of type string annotated by column decorator. Email attribute, besides being a string, will also be unique. Therefore, in addition to column decorator, we will use unique decorator as well. Finally, we will add created at and updated at attributes. They are utility attributes, or columns of date type, and usually are used to track when resources are created or modified. We will annotate them with created at and updated at decorators respectively. That way, created at and updated at columns will be filled out automatically. And since we won't need to pass them when creating a user, we need to make them creation optional. Next, let's make Sequelize aware of the user model. In base repository constructor, add an attribute called models to Sequelize configuration. We can either pass it an array of the models, or better yet, we can point it to the folder where the models are located. This way we don't have to add each new model every time we create it. Now we need to somehow create a table in the database based on the Sequelize user model. Normally, you would use Sequelize migrations for that. However, our project is really small and we can get away with using sync method on Sequelize client. Let's go to index.ts file in the src folder, and instead of Sequelize authenticate method, we will use Sequelize sync method. We will also update console log statements for success and failure to successfully migrated tables and failed to migrate tables respectively. Alright, let's try it out. First, be sure you have your database running. If you are following along, you can spin it up with the command docker compose up-d next. We will use the command npm run dev. And in a second or two we can see a message that the tables were migrated successfully. This is great. Let's continue. But before we do that, if you are learning something new, please hit the like button and subscribe to our channel for more videos like this. The next step will be to enable users to create and modify user resource that we just created. We will create an application interface for the API consumers to interact with the user resource using HTTP methods. The interface we create will end up calling methods on the sequelize user model to store and update data in the database. Sequelize models are very powerful, and we will be using them throughout the application as opposed to translating them into application-specific modes. Although we don't need model translation, I still like to wrap up sequelize method calls inside a repository for clean and dry code. In the base repository, let's export constructor type. We will need it to be able to use mixins pattern. Since TypeScript rules we defined are pretty strict, TypeScript will complain about explicit any. We can turn off this rule in slint.config.mjs file by adding a TypeScript slint no explicit any off to the rules object. Let's create add user repository.ts file in src data repository folder. In this file we will import user model, base repository and constructor type. We will export a generic function called add user repository and pass it base of type tbase. This is a boilerplate code needed for creating mixins that I took from TypeScript documentation. Add user repository function returns a class that extends base, which in our case will be the base repository. We are going to create getUsers method. This method will return user find all call that queries all the users. In most cases, not limiting how many records a query can return is never a good idea. Therefore, we will pass an option to find all method to limit how many users we return. Find all method can take other options, such as where, to define a query, as well as offset and order by. You can check sequelize documentation for more information. The default limit that we use can also apply to other models that we create in the future, like posts or comments, so it is a good idea to define the default limit on the base repository parent class. This way child repositories can have access to it. We will define default limit as 100. The next method on the class is getUser. We will call findUser by park method on user model. Finally, let's define createUser method. It will accept a name and an email user attributes and call create method on the user model. Now we need to add user repository to the base repository. Let's do it in index.ts file of the repository folder. We will import add user repository function. Then we will define a combined repository and assign to it the result of calling add user repository function with the base repository argument. We will instantiate and export default combined repository. I hope now you will have a better understanding how mixin pattern works. Much like Russian dolls, we stack add repository functions on top of each other. The repository is ready to go. Let's enable an API access to it. We will do it by defining routes. In src, routes folder let's create user.ts file. In this file we will import express, request, and response from express and repository from repository. We will export function create user routes to which we will pass an express app as a parameter. In create user routes function, we will call a get method on express app to define a mechanism to accept HTTP GET request for user routes. The root handler will call getUsers method on the repository and respond back to the user with JSON object containing the users. Next we will call a get method on the express app to fetch a single user. We will add a :id to the end of user's path. This is a route parameter. We can access it on the params attributes of the request. Since a path is a string, the ID parameter is also a string. In order to pass it to the getUser method of the repository, we will need to parse it as an integer. We will return a user as a JSON object by calling a JSON method on the response. Finally, let's call a post method on the express app. We will parse the name and the email values from the request body. The reason we can do it is because when creating an Express server, we attached Express.js middleware to it. This middleware takes the request stream, translates it to an object, and assigns it to a body attribute of the request. The parsed user payload will be passed as an argument to create user method of the repository, and then the created user will be sent back as a JSON response. Creating a user may not always go well. For example, a user's email may already exist and a query to create a user with the same email will be rejected by the database. To handle errors, we wrap user creation in try-catch. In the catch block, we log out an error and return an error response with HTTP status 400, so the recipient of the response knows creating a user didn't go so well. By the way, by default Express response will send HTTP 200 OK status. That's why we didn't explicitly assign response status earlier. But if we need a different status, like 400, we need to assign it explicitly. Now, let's add the routes we created to the Express server. First, we will create an index.ts file in the routes folder. In this file, we will import Express and create user routes function. We will export create routes function, inside of which we will call create user routes function. Finally, in the server.ts file, we will import create routes function and call it before returning the app from create server function. We are all set. Let's test our work. Be sure the Express server is still running. Let's go to API-test.http file and send request to get users. Obviously, there are no users in the database, so we get back an empty array. Let's create a user by sending a post request with the payload containing a name and an email. Another important thing to remember is that the Express.js middleware will parse the request body only if the content type header is application.json. Please, be sure to not forget content type header when making post and put requests. We can see that the user was created successfully. Now we can fetch that user by its ID. As you may have noticed, the user response contains all the fields from the user's table. Sometimes it is desirable not to expose all the fields to an API consumer. For example, you may not want to return user's password field in the response. In our case, let's say we don't want to return created at and updated at fields from the user's table. We can easily turn off those fields by overriding to JSON method on the user model. In user.ts file, let's add to JSON method to the user model. This method will return an object in which we will splat all the properties of the model with this .get method. Then we will add created at and updated at properties to the object and assign undefined values to them. This will essentially hide those properties in the response. Let's go ahead and test it. In API-test.http file, let's send request to get users. Now we have one user, since we just created it, and this user doesn't have created and updated properties anymore. Awesome! All we have to do now is to knock out put and delete requests. Back in adduserrepository.ts file, let's add an async method update user. It will take an ID and an object with user attributes as parameters. Now, name and email can be optional, because we may update only either one of those attributes or both. There's an update method on the model to update a user where user has a certain ID. However, when updating models, I like to fetch a record first, assign properties that need to be updated, and then call save method on the model. This way I'm able to first check if a record actually exists, and if it doesn't, send an appropriate response back. And if the record is found, I can return the updated record back. Let's do just that. We will use getUser method to fetch the user first. If we can't find the user, we will throw an error with the message user not found. Next, we will use fromEntries method of the object to filter out undefined user attributes. Finally, we will set the attributes that need to be updated on the user instance, call save method, and return the updated user. The delete user method will be a bit less involved. We will simply call a destroy method on the user model and pass it where object to filter by user ID. Essentially, this will run a query to delete a record. Destroy method returns 0 if the record is not found, or 1 if the record is successfully deleted. Back in user.ts file in the routes folder, let's call put on the Express app to update a user by ID. Much like in the post method request handler function, we will parse user ID and user payload from request parameters and request body respectively. We will call update user method that we just created on the repository. If everything goes well, we return the updated user in JSON format. If things go bad, for example, we can't find a user record to update, we will catch, log, and return an error response. Finally, let's call delete method on the Express app to delete a user by ID. We will parse the user ID from the route params and call delete user method on the repository. We will send the result of this operation as a JSON response to notify the API user if the user record was deleted. As we already know, this result will be either 0 or 1. We are all set. Let's test the code. In the API-test.http file, send a put request to update user's name to John for the user record with the ID of 1. The API returns the updated user record. Next, let's delete the user records with the ID of 1. We got user deleted response also as 1. The user record was successfully deleted. We can confirm that by sending a request to get all users. Now users array is empty. The user API that we just built is working. We are all set. As you may have noticed, we took a pretty relaxed approach to creating and updating users, assuming we will get the correct data. This may not always be the case. To learn how to use Sequelize's built-in validation and how to handle errors in Express API more elegantly, please watch this video next.